guys, welcome back. Thank you for hanging around. I know it was a wait, but today I'm going to give you the answers to the questions. If you watched the other video, the first portion, you would have seen things like this. See? It lifts up in the air. Now you may think it's springy, but not enough to do this. What makes it do that? Not a suction. It's not a vacuum. Is it the Bernoulli principle? Is it that it's springy and it bounces up? Is it laminar airflow? You're saying to yourself it's a trick or something. It's not. The pressure of the water coming down onto the surface at just the right angle causes a little bit of laminar flow where it's very smooth and it causes a sheeting action. But that sheeting action allows the water to flow over it very fast. It actually is causing a lift, like an airplane wing, causing a drop in air pressure above the foil. Even though the water's pushing down, it's moving so rapidly that it's forcing the air to flow with it. The foil lifts up because the air underneath is pushing up on it. It's that the air molecules are spread out thinner. Therefore, they have less resistance to push down with the rest of the atmosphere on top of them. So they lift up. So if you said the Bernoulli principle, you were correct. The Bernoulli principle states that a faster moving stream causes a lower pressure and a slower moving stream causes a higher pressure, which lifts things into the air. This is the Bernoulli principle. So take a piece of paper, let it form a wing. That is exactly how an airplane works. The air going across the top of this is actually moving faster than the air going under it. Therefore, the air going under it lifts it up. That's how an airplane flies. Literally, the air flowing over the surface of the wing, which is teardrop shape, comes down. That teardrop shape means the air going under the wing is actually slower than the air falling down the back trail of the wing. Therefore, it lifts the wings, which lifts the plane. But the amount of actual surface that's taking place across is only about 3/4 of an inch thick. It's that thin that lifts the entire plane, okay? So the Bernoulli principle is actually part of fluid dynamics. And Leonardo da Vinci was the first person to truly study fluid dynamics, how fluid flows around objects. And he was the first one to notice vortexes and eddies coming off of rocks in a stream. That's fluid dynamics. So the Bernoulli effect is everywhere. So there are many examples of the Bernoulli principle that we experience every single day in our lives that we don't even know about. Like the carburetor in a car is the Bernoulli principle. A perfume bottle is the Bernoulli principle. The wind picking something up. A tornado lifting the roof off a house and lifting it up. A pinwheel, when a fan spins around, blows air. The wind whipping our hair. Blowing out a candle. Confetti. Smoke going up a chimney. The way things interact with a lower density of air compared to a higher density of air, or a lower density of water to a higher density of water, or anything where there's a gradient between a low and a high density of atoms or molecules is basically the Bernoulli principle. So here's a few more examples that you can try at home. So you're going to need a cardboard tube and a scissor. Remember to ask your parents for help working with scissors. Okay, so you take your cardboard tube and you're going to cut it in half. And then you're going to want to cut that in half again down the middle of the other side. Approximately right across from the first cut. Now that we've cut this, we're going to just take them and place them on a counter. So now I'm going to take my cardboard tube, and I have to have a few of them cut up, and I'm going to just put it down on the counter like this. I'm going to blow these tubes. What do you think is going to happen? Notice that when I blow under the tube, it doesn't move. If I blow on the tube sideways, it moves very easily. And this works with different size tubes. Now, see, I hit it sideways. If you were to take a tube and blow on it dead on, it'll stick to the counter. So it's just a matter of blowing dead on. So What happens if you take a tube and put it behind a tube? As you can see, any tube that's not dead on won't stay firmly attached. It's the same reason that a house can get blown away in a tornado. If this was flat, or if this was inverted, look, just blows right away. But because it's shaped this way, like an airfoil, like the wing of an airplane, it's going to want to have lift, but the air flows faster underneath the tube than it does across the surface. So the air moving faster underneath it sticks it down to the surface. This is the same reason that a spoiler on a car holds a car down. So that's another example of the Bernoulli effect. Watch this. When I blow quickly and the tubes are just the right distance apart, the air pressure between the two tubes is less than the air pressure around them. Therefore, the two tubes squish together. So in this example, all you need is aluminum foil and a hairdryer. Take the aluminum foil, crumple it up into a ball, roll it really tight and compact so it looks like this, okay? And I rub it on the counter and I make the rough edges as smooth as possible. It's not perfect. Then you take a hairdryer. Now for you kids out there, you have to do this with the supervision of an adult if you're working with electricity or with heat. Okay, plug the hairdryer in, hold it so that it faces up. Turn the hairdryer on, it's gonna be loud and noisy, and what I'm gonna do is take the ball and I'm gonna place it into the stream of upflowing air. What do you think this ball is gonna do? Let's find out. Oh, and by the way, don't turn the hairdryer on full force. It may not work. You may have to be on a low or medium setting. Let's try it. Hairdryer's on, medium. And the Bernoulli principle. Amazing. I'm moving it closer. And that's on high speed now. And there you go. There you have it. That's the Bernoulli principle, demonstrated with air and with water. You can see other beautiful examples of the Bernoulli effect, like when you take a drink from a straw, as you suck up through the straw, the water goes down because the atmosphere is pushing down on the liquid, forcing it up through the straw. All you've got to do is drop the pressure at the top of the straw a little bit, the atmosphere pushes down, the liquid goes up the straw. There are several examples of the Bernoulli principle, which I did not cover at all. For more examples that I can't show here on YouTube, please join my Patreon. That's where you'll get to see more examples like the straws or the confetti. So please like and subscribe to my channel. Thank you. I wanted to let you know, please ring the notification bell. Select all, and that will give you all the notifications for whenever I release videos, which are coming faster now. Have a great day. See you in the next video. Subscribe, like, you know. If you want to see some more beautiful examples of the Bernoulli... If you want to see some more beautiful examples of the Bernoulli...